Hello and welcome to a video tutorial on building a rich internet application with Vaadin. In this course we will go through the process of creating a fully featured web application written entirely in Java using Vaadin as our framework. We will begin with literally nothing and finish with a setup development environment and a rough specification for our software that we will keep developing throughout the rest of this course. To develop an application with Vaadin we need the following: Java Development Kit, Vaadin, and a servlet container like Tomcat. However, it would be very difficult and time-consuming to write software with just these tools. We need an integrated development editor. One of the most popular IDEs is Eclipse, and it is officially supported by Vaadin. This video will show you how to get and set up Eclipse to work with Vaadin. Let's get started. But before we do anything, be sure to have Java installed. The latest JDK can be found at java.com. First things first, let's visit the Eclipse download page and get Eclipse for Java EE developers. We use this version as it ships with a number of tools useful for developing web applications. Once the download is complete, we need to unpack its contents to some easily accessible location. When we run Eclipse for the first time, it will prompt us to enter workspace level directory for it to keep projects and settings in. After that, we should see a welcome screen. So, now we have Eclipse, we still need Vaadin and Tomcat. Let's start with the latter. We will install it directly from Eclipse. Open Help, Install New Software, then select Eclipse WTP software repository from the list of available sites. After a short while, a list of add-ons should show up. We need the latest version of WTP SDK, together with patches. It will allow us to run and configure Tomcat Web Application Server directly from Eclipse. Let's select WTP SDK and install it. Eclipse will start the process of downloading and installing the plugins, and we can take a short coffee break. Once the download and installation is complete, we must restart Eclipse for the changes to take effect. OK, WTP SDK is now ready. We can install Tomcat. In Eclipse's preferences, search for Server and select Runtime Environment. The list is empty, so let's add a new Tomcat 7 server. We can either provide an existing Tomcat 7 directory or download and install a suggested version. Okay, that's 2 out of 3. We just need Vaadin to be ready to code. Let's install it similarly to how we installed WTP. Help and install new software. This time we need to use Vaadin repository at the address http Vaadin.com/Eclipse. Let's install Vaadin plugin for Eclipse. In the middle of the downloading and installation process, Eclipse will prompt for installing on-site content. Since we trust Vaadin, we will allow it. After Eclipse restarts, we are ready to work. We have installed our environment, set up its Tomcat, and the official Vaadin plugin. Before we start though, it would be great to know where we can look for some advice in case we got stuck. The first and most important place should be the official Vaadin forum, located at vaadin.com/forum. This is the place where your question is already answered or will be answered by the friendly and helpful Vaadin community. Another place to ask questions is Stack Overflow, which allows you to tag your posts with Vaadin. In case you need it, the full documentation of Vaadin API can be found at vaadin.com/API. To get you started, there is a 10-minute video at vaadin.com/learn. Finally, the book of Vaadin is available online at vaadin.com/book. It has hundreds of pages filled with useful information, guidelines, and explanations of almost every element you can find in Vaadin. That's probably one of the best resources to learn Vaadin, and it's available right away. Now we are ready to code. Let's move on to the next video. Eclipse, our development environment of choice, is ready, so let's give it a go. In this video, we will see how to create a Vaadin project, which we will convert into our fully featured application later on. We will also learn how to debug our code. Under the New Project menu, there is an option for creating a Vaadin 7 project. Clicking it will open a wizard that will guide us through the process of creating an application. The only required field here is the project name. After providing it, we can click Finish, and the wizard will use the default values and generate the project based on them. The options on the first page of the Setup wizard allow us to configure the deployment settings, the server which we will deploy the application to, and its configuration. Most importantly, we can also change the version of Vaadin we want to use in our project. The second page configures the source and the build folders. The third page defines web module, that is the context which the application will be available under, and the directory with external content. Finally, the last page deals with application template. Here we are able to set up the application name, packaged class names, as well as the name of the theme used by our code. After we click Finish, we are shown a prompt about automatic resolving of dependencies. We just need to acknowledge it. Our project is now created. Let's have a look at the code. In Project Explorer, in the source folder, there is a package with the name we provided, and in it, the base class for our application. You can see that it extends UI, which is the topmost class in component hierarchy. The UI class represents either an entire browser window or a part of a page the application is embedded in. Each Vaadin application needs at least one subclass of UI. There is one method in our class, init. This method is used to add components that will be visible to the user and to initialize any other functionality of our application. In other words, this is an entry point to our code. As generated by the wizard, the initial code is very simple, but it gives a great overview of Vaadin philosophy, that is, to develop web applications the Java way. What this code does is as follows. First, it creates a layout component that contains other components, and sets it as the contents of the UI. Then, it creates a button that when clicked, will add a label to the layout. This is the pattern we will follow many times. We will populate layouts with different components and implement interactions in response to various events. That's very similar to developing a desktop Java application with Swing. Okay, we have the code. We know what it should do. Let's see how to run and debug it. To run the project, simply right-click it in Project Explorer, then select Run As, Run on Server. We will be prompted to select and optionally configure the server. After a short while, our project will be compiled and deployed, and a new tab with browser will open. Now, let's see what happens when we click the button. Hey, it works! Now, every time we change our code, all we have to do is wait a moment for Tomcat to reload the compiled code. Thus, we do not have to restart the server all the time. We can keep it running. Let's stop the server and try to debug the code. Let's place a breakpoint that will stop the execution of our application. Now, when we click the button, the execution will stop, thus allowing us to inspect the server-side code. There is a number of reasons when this is desired. Most obvious is, of course, to see if a place in the code is reached during the execution. Other reasons include checking variable values at runtime, tracing the execution path, and so on. Let's see if we reach our breakpoint. Hey, that's it! We have successfully created a Vaadin 7 application. We run it on a local server and we were able to debug it. Next, we are going to take a look at the variety of components Vaadin has to offer. So far, we have configured Eclipse and managed to run and debug a sample code created by the Vaadin plugin. We should start developing an application, but what are the most essential building blocks, that is, the elements of the user interface? This is something we will figure out during the next few minutes. Vaadin is a framework for developing web applications with Java. As it is typical for each framework, it contains over 100 of ready-made UI components. Regardless of what it does, each component contains an icon and a caption. The components can be grouped into 4 sets. The first group contains just a few components. They all have well-defined properties and role, but their interaction with other components is limited, as is their ability to be replaced by a different component. This group includes all components that embed external contents into our application, such as Flash or Embedded. The group of fields is probably the biggest one. Almost any component you can think of is a field, meaning that it stores a value that can be entered by the user or set programmatically. Examples include the obvious components like text field, checkbox, date field, or slider. Selects is a group of fields that, in general, allow the user to select a value or values from a specified collection of options. Combo box or list select are obvious examples. Vaadin handles selects really nicely. In most cases, you can substitute one select with another without changing your code, except for the place where you create that component. Final group are the component containers. Their only purpose is to arrange other components they contain. The most notable components in this group are the layouts, like horizontal, vertical, grid, or CSS layout, but also horizontal and vertical split panel, tab sheet, or panel. The number of UI components available in Vaadin is enormous. The majority of the most commonly used ones can be seen in action without the need of writing even a single line of code. There is something called Vaadin Sampler, available at demo.vaadin.com/sampler. It is an interactive demo of almost everything the framework has to offer and more. Toying around with Sampler for a few minutes gives a great overview of Vaadin's possibilities. What we are most interested in is Sampler's ability to show the source code of whatever is currently displayed, and we do it by simply clicking the middle icon in the upper right corner of a browser window. Moreover, Sampler allows us to edit some of the component's properties in an inline editor, meaning that we can directly see what the effect of the changes will look like. Alright then, we have seen how the major components look like and what they can do. Time to investigate the interactions between them. We are almost ready to start real coding. Our Eclipse is up and running, we know what components Vaadin has to offer, but how do we work with components? This video will hopefully answer that question. Let's take a closer look at the sample project created by the Vaadin plugin. It contains a button that, when clicked, adds a label to the current layout. When the button is clicked in the browser, the information about that event is sent to the server, which in turn broadcasts the event to all registered listeners. Sounds familiar, right? Right, because this is the observer pattern, widely used in Java and everywhere else. What is more important is the fact that this event sending from the browser to the server is done automatically by the Vaadin framework. There is no need for us to even consider the fact that the end user is accessing our application through a web browser. What we do is that we create a button and assign a listener to it, pretty much as if we were developing a regular desktop application. Let's find out how we can make more use of that sample application and learn a bit more about the events. Instead of the text that says "Thank you for clicking," we would like to echo a text entered by the user. Let's add a text field next to the button. And modify the listener of the button to include the value of that text field. Okay, let's run it, type something, and see what happens when we click the button. That looks great! Our code seems to work. Whatever we type gets repeated in the label. I wonder what happens when we do not enter anything. Seems that we get nothing. It would be better if the user would not be allowed to click the button unless the text field has something in it. Let's see what are the events we can listen to. Vaadin code convention follows the standard practice of Java. Events can be listened to by registering listeners with a method called addSomethingListener, where something is of course the name of the event. Let's see. Add value change listener sounds about correct. We are interested in reacting to the changes in the value of the text field. If the value is empty, we want to disable the button. Since the value of the field is empty by default, we also want to disable the button initially. Let's write some code then. And let's try it out. It looks like it's working. Sweet! Okay, but there is still some room for improvement. It would be nice to have the button state instantly changed when we start typing the text, not when we leave the text field. When the value is changed, as long as we are editing it, the component is smart enough to know that this is not the final value, so it waits until it loses the focus to notify the server that its value has changed. Let's check if there is another event we could use. There it is, text change event. Let's add another listener that will update the state of the button and try it in practice. A side note at this point, text change events are sent every time something in a component happens, which may significantly decrease the performance of our application, especially if there are many of them at the same time. Well there, it seems to work. One more thing though. After clicking the button, we do not want the text to stay in the field. Let's set the value of the field to nothing. All components that are fields contain a method called setValue that, as you could expect, changes the value of the component to something else. It should also broadcast events if the new value is different from the previous one. Let's modify the button click listener and see if it works. It does. We are done with this simple exercise. We have learned how to listen to events. This is probably the most important part of implementing anything with Vaadin. Next, we will finally decide what application we are writing in this course. So far, we have done everything that is needed to start coding, but we have not decided on the most important thing, what we will be coding. The application should resemble real-life software, so there are several implicit requirements. We have to use a database, there needs to be some simple user management. Above all, the application should be fun to develop. How about a recipe book? A place where we could not only store recipes, but also share them with friends, show pictures of our food, and comment on other people's work. Thanks to Vaadin, we should be able to develop a rough version in just a few hours. We would allow registered users of our recipe book, let's keep that name for now, to store recipes of how to make delicious food with pictures. We should allow everyone to browse through the recipes and search by name, by ingredients, or by author. Registered users should also be able to comment on other people's recipes. A simple voting system would also be nice as well. Finally, we would like to be able to bookmark or share the most interesting or inspiring recipes. Of course, above all, we would like our application to be visually appealing. Unfortunately, that one requirement is something that Vaadin cannot fully guarantee. For sure, the framework can offer all the tools to make the application look beautiful, but the matters of user interface and experience design are outside of the scope of this course. Fortunately, you can find inspiring videos at Vaadin's official YouTube channel. Since we do not have the name for the application, let's make a competition. Until end of November 2014, submit your proposal to my email address, miki@vaadin.com. A group of Vaadin experts and developers will select 3 best proposals during the Christmas break of 2014. The winners will receive a Vaadin t-shirt and the most recent book of Vaadin. We will contact the winners and announce them publicly in early 2015. The application we will develop throughout this course will be publicly available and will be renamed to one of the 3 winning names after the competition. So, enough theory, let's move on to practice and to the next section. Previously, we have set up Eclipse, went through the basic principles of web application development with Vaadin, and defined rough requirements for our sample application, Recipe Book. In this section, we will go through content navigation. While building our breathtaking recipe book, we will learn about views, navigation, layouts, and windows. Let's get started. An application typically contains views that group UI components and allow users to perform certain actions. Let's take a look at some of the requirements set for a recipe book. The users should be able to log in when required and register before that. So registration form seems like a natural candidate for the first view, register view. Searching for recipes is also one of the requirements. Presenting the search results in a separate view is a good idea. We must be able to view recipes, comment them and rate them naturally. Let's make that one view, food view. Finally, registered and logged in users should be able to manage their settings, username, email address, password, and the like. That should be a single view as well. Let's name it Settings View. Views in Vaadin are interfaces that define only one method, enter. This method is, as you probably guessed, called whenever a view is displayed. View being an interface has a significant advantage over other solutions. Any UI component can be converted into a view by just implementing that interface and defining meaningful behavior upon entering. In most cases, the base class will be a layout, a component that groups other components that will initialize any external resources upon entering. A good practice is to put all the views so that each view occupies its own package in a common package called views. The first view we will create will deal with registration. It should be a basic form with a number of components on it. Let's create a new class. In Views Register and name it Register View. It must implement view, and as a basis we will use form layout. This layout arranges components one below another with caption of each component placed to the left, meaning that they will end up aligned just like in a typical form. Exactly what we plan to achieve here. There. Now we need some components. Let's put a text field for email address, 2 password fields for password, and a checkbox to accept terms and conditions. We will add those components to the layout when we construct it and write interactions between them later. That should do it for the first view. Let's move on to another. Once the user registers, we should do something. Maybe show the settings view so that the user can provide more information. We do not need a form layout in this case. A regular top to bottom arrangement should be fine. Let's use vertical layout as a base class. This means that the contents of our view will be arranged one component below another, starting from the top of the page. We will also need buttons to save and cancel changes to the user's profile, apart from a few other fields. In addition to the user's profile information, it might be a good idea to allow the user to quickly view all of the recipes that he or she had written. Since we will have a search results view, let's just make a button that will open a predefined search results. Now, this brings us naturally to the third view, search results. The search panel should be located at the top, and the results in a tabular or list form should occupy the significant part of the bottom of the page. We have no idea what components we use for this layout, so let's leave it blank for now and come back to it later. Last but not least, the food view. This is where we expect the users to spend the most time with our application. We need flexibility in arranging components to our liking, and there will be plenty of them. Let's use the fastest and one of the most flexible layouts available, CSS layout. We can define the main areas of the view. Let's say comments at the bottom, picture and ingredients next to one another in the top, and recipe itself in the middle. But let's keep the view empty for now. We will add more things as we progress with our application. It seems that we have the steps for all 4 views that we need in recipe book. It's time for us to learn how to navigate to them, which is what we will do in the next video. The development of our recipe book had an easy start. We have just created the views for it. Now that we have them, let's do something. More specifically, let's connect them to our application so that we can navigate between different views. Navigator is an entity that, manages navigation between different views. It's not a component. There's no UI for the navigator. It works behind the scenes. Instead, the navigator determines which registered view should be shown in the designated area, based on the URL of the page we are accessing. Navigator can also be used to navigate to a page programmatically. It requires 2 things to work: an area to display current view and registering the views themselves. The area to display views is typically a layout into which the functional part of our system, the view itself, is added. First, we decide which area will be used for displaying views. In our soon-to-be-famous recipe book, we would like to have the topmost part of the screen stay unchanged, regardless of the view we are in. We will put some important components there, like login form or information about current user, application logo, and the like. Let's prepare that first and leave a placeholder for our views to populate. Once we have it ready, we need to register views with the navigator. There are different ways of doing that. The straightforward one is to register an instance of a view with the navigator. The biggest disadvantage here is that we have created an object without being sure we are ever going to use it. In other words, we would be wasting resources if the view was huge. Instead, we can register a class of that view. It will be instantiated when we navigate to that view for the first time. This is memory efficient, but at the price of speed. If the construction of a view takes a significant amount of time, the process of creating the view will be unnecessarily delayed. Finally, we can register a view factory. This allows us to dynamically create views depending on what the URL of our application is. Naturally, this is the most flexible and most advanced solution. Our simple application does not need such a sophisticated approach. The more advanced ways of using Navigator are covered in the book of Vaadin. For now, let's register views by their classes instead. We will register search view also with an empty name. We want it to be available by default when someone enters our application. Before we try it in practice, let's add some buttons to switch between the views so that we do not have to retype URLs all the time. Let's create one button per view and navigate to that view when the button is clicked. Okay, there, let's try it out. You can see that the buttons work and that the URL is changed. We can also type URL directly and a proper view will be shown. Most importantly, basing our application on views and Navigator adds support for back and forward buttons in the browser, like this. Lastly, we can now easily bookmark the page to come back to it later. All that with just a few simple lines of code, creating the Navigator and registering the views. Of course, we should keep in mind the fact that the state of an application may depend on more factors than just the URL address. This is especially true with Vaadin. Navigator does even more. It supports passing parameters through the URL address. We will get back to that later when we connect some data to our application. Now that we have a navigation support, we can show some views. Well, it's time for us to do a bit more work on the contents of those views. Let's move on. So far, so good. We know how to create views and how to navigate to them. When we created stubs for our views, we used different layouts as their superclasses. Let's talk a bit more about what layouts are available in Vaadin and what we can do with them. Before we start though, we should remember that each component in Vaadin can have a caption, and the vast majority of components can be sized. The two most commonly used layouts, horizontal and vertical layout, are very straightforward in their functionality. They arrange components by displaying them in cells, horizontally or vertically. Both layouts have the option to set additional spacing between the cells. It is also possible to specify the expand ratio of different cells. When the application is resized, by default, each cell grows or shrinks at the same rate. We can override this behavior, for example, by allowing one cell to grow twice as fast as the others. What is tricky here is that the components in the cells are not resized. It's just the cells. We can have the component always take the entire space available by calling that component's setSizeFull. Finally, we can specify alignment of a component in a cell with the method setAlignment. There is another layout available in the core of Vaadin that might come in handy. Grid layout arranges the components in a tabular form, with a given number of rows and columns. As with horizontal and vertical layout, it is possible to specify alignment of a component in a cell. Grid layout also supports spanning of components over some rows and columns, but does not support overlapping. We could use grid layout to arrange a simple login form that we will place in the top right corner of our application when the user is not logged in. Let's open the main application UI and create one. We need 2 rows and 2 columns. Let's add fields to the layout: email address and password. In the bottom row, we should have 2 buttons, one for resetting password and another one for logging in. We will configure the listeners for the buttons later on. Let's talk about layouts a bit more again. Form layout is something we used previously to show a form, and that is the sole purpose of this component. Both horizontal and vertical layout display component captions above the components. Form layout always displays them on the left. We used CSS layout to give flexibility to the view. CSS layout is the fastest in terms of rendering in the browser, but that comes at a price. All component sizing and positioning should be done in CSS. We are done with the overview of layouts. Next, we are going to use another way of showing content to the user: windows and notifications. Our application is getting more advanced, at least from the UI point of view. We have this neat login form. Next to it, there is a title bar of our application, and the central part of the screen is reserved for the current view. That login form could use some interaction. For now, we do not have any user authentication. Let's make it so that after clicking login button, we will display some meaningful information. Let's add a click listener to the login button. In it, we will just display notification that logging is currently disabled. Vaadin offers a variety of notifications, all available in the notification class. Let's display the default notification and see what happens. To make development less troublesome, notification class has a bunch of static methods for the most common use cases. While we still can create a notification object and configure it to our liking, almost all of the time we will be just fine with those helper methods. That's very convenient. Does not look like an error message, rather just a plain notification that disappears quickly. Let's try again, this time setting the type of the notification to something else. There, much better. While we're at it, let's implement password resetting. Since that operation is important in terms of security, we don't want it to happen automatically. It would be better if the user confirmed that indeed they want to reset the password. Ideally by typing the email address. Let's open a pop-up window inside the application for that. Vaadin's base class for sub-windows is window. Let's create a new class that will extend from window and put any window-related stuff there. We want to have a text field and two buttons, cancel and confirm. The cancel button should just close the window. And the confirm button should of course reset the password and send the email to the user. Let's just close the window and show notification instead. Let's make a vertical layout into which we put two components, a text field and a horizontal layout with those buttons. Okay, we have the window class, now let's connect it to the reset password button. We need a button click listener in which we construct the window. Windows differ from other Vaadin components. They cannot be directly added to other components. Instead, they should be added directly to the UI with a dedicated method. Let's get the current UI and add our window there. And try it out. Great! Everything works so far. But what's this? We can click outside our window and open another one and another one. That's not good. We should prevent the user from doing that. Fortunately, Vaadin has a built-in support for that. We can set our window to be modal, which will prevent the user from clicking anywhere outside it. We can also make it not resizable and define fixed dimensions instead. We will also tell the window to show itself in the middle of the screen. One important thing before we move on though, the modality of a window is purely browser specific. It can be ignored with a clever JavaScript or CSS styling. Therefore, we should never rely on the fact that a window is modal and other components are inaccessible. Okay, that seems to work. Our application looks way better than when we started, and we even implemented some simple actions there. More importantly, we have learned about different layouts, windows, and notifications. Time to use what we have learned so far and add some of the remaining components to our application. That's something we are going to do next. Our application supports navigation, shows basic information when we attempt to log in or reset password, but we are still missing the contents of two of the most important views. Let's make a stop for the main view. We will not be implementing any functionality. We'll do that later. Let's open the food view. We have already outlined the way the components should be organized. A picture of the food, the ingredients list, and the recipe itself should occupy the majority of the space available. We decided to use CSS layout, which means we will position the components later using CSS. How do we reference the components from the CSS? Let's find out. The typical approach for styling an HTML element with CSS is to somehow identify that element, for example by setting its class name to something easily recognizable. In the CSS, we can then reference that particular class and provide styling information to it. Each component in Vaadin has methods related to those style names. Apart from regular getter and setter, there are two even more useful ones: add style name and remove style name. As method names imply, they allow modifying style classes of a component, usually one style at a time. More styles can be added and removed as well, as long as they are space separated. However, what is even more important is the fact that this works with all components and all layouts. Some layouts use inline styles directly in the HTML element, which cannot be overridden. Fortunately, CSS layout does not. Let's add some components and assign their style names. We will return to styling later on in the course. For now, it is important that our views are not totally empty so that we can start implementing some functionality to the system. In our food view, there must be a list of ingredients. It will likely be hierarchical. We might want to have different things to be prepared for the main dish, like sauce, filling, etc. Let's use a tree for that. And assign it a proper style name. The picture is going to be displayed with a component named image. We also need a style name for it. The instructions for preparing food will be shown as text area, which supports editing multi-line text. The last component occupies the bottom of the page, and it will be a list of comments. Let's use a table here. We will style it to look less like a table later on. That's it for the main view. Let's try it out. Oh well, it does not look that good. To be honest, it looks terrible. Fortunately, this is just a styling issue. The important thing is that the components are there and we can start programming interaction between them. Seems like our recipe book is getting more concrete. We have views for our application, we know how to use them, how to arrange components, and to refer them in CSS later on. Time to add code that actually does something. Let's do that in the next section. Our application so far consists of several views and a number of components. We can switch between them and admire the default look of components forever, but there is very little we can do with our system just yet. We need to store the data somewhere, and we need a model for that data as well. Database connectivity is something we will cover in this section. Let's get started then. Before we can connect to the database, we need to model the data we would like to store in our application. Then, we need to be able to access that model with Vaadin, meaning that we have to arrange the UI components, views, and the like. Finally, we need to connect the database to store the data. The model of data we need to store in our application is very simple. We need to be able to store recipes, users, and comments. Let's start with the user. Almost every web application contains an entity named user. Vaadin developed application are no exception. Our user should contain the following information: email address, password, display name. A recipe is the central concept of our software. We need to store, apart from obvious things like name of the recipe and its author, also the ingredients list and the recipe itself. It would be nice if we also store the date when the recipe was added. Finally, a list of tags would be also useful to allow other users searching for the recipe based on the tag. Finally, comments. Since only the logged-in users are allowed to comment, we will naturally store a user and also the date of adding the comment and the comment itself. We will also give the users an option to rate recipes. Let's store the rating with the comment as well. Okay, our model is ready. We will implement it in a moment. Once we do, how do we access it with Vaadin? Vaadin data model is an additional layer of abstraction between the UI components and the data source. It consists of three parts, which are declared in the framework as interfaces. What it means is that it is possible to switch one data source with another without worrying much about what provides that data. At the most general level, we have containers. They contain items, which group properties. A property is just a type value pair. In most cases, the value can be changed, and doing so will trigger property value change event. An item is a collection of properties, where each property is uniquely identified with a property ID. Finally, a container associates items and corresponding item ID. Moreover, all items in the container contain the same property types and property IDs. Whenever an item is added to or removed from a container, item set change event is broadcasted. Some container implementations allow also adding or removing properties. In such case, property set change event is broadcasted. The easiest way to understand Vaadin data model is to apply it to relational databases. In the most general form, a container is a table, an item is a row, and a property is a column value of that row. That's about it. Let's set up a database for our application. We will do that in the next video. So far in this section we have created a data model for our application and described the structure of a Vaadin model. Time to focus a bit on the backend part. Let's put our model into a relational database so that we have a place to store data with our application. In this video we will be using PostgreSQL, but because of Vaadin data model, it is possible to use any other relational database as long as the structure of the database matches our model. Let's check the elements of our model: user, recipe, and comment. The relations between them are straightforward. A recipe requires a user and a comment requires both. We can make thus three tables: recipes, users, and comments. There is a straightforward mapping from the attributes in our model to the columns and types in the database. Finally, we add foreign keys to represent relations. Note that we are not specifying any additional constraints in the SQL code. This is because we will have our application to maintain the correctness of data. We will just ensure the integrity when it comes to relations. Let's create a new database on our database server, and let's create the structure we just decided. For security reasons, we should also create a separate database user which will be used by our application. The database we will be using in this video will be used locally on our development machine. We need to follow the same setup instructions for our production environment as well. We will be connecting to our database through JDBC, Java Database Connectivity. It is a standard solution, but it requires us to have a JDBC-compatible driver to establish and maintain a connection to our database. The driver for PostgreSQL is available at jdbc.postgresql.org/download.html. We should always download the driver that matches our Java version 1.6 and database server version 9.3 in our case. The driver should be downloaded into webinflib folder of our application. It will be automatically added to the class path and thus available to our application. We're done. Our database is up and running and we have the latest drivers. Let's see how we can connect to our database. Time to move on to another video. Before we go, just a side note, Vaadin offers another way of connecting to a database using a container dedicated to work with Java Persistence API. It is especially helpful when developing enterprise-level applications. We get back to JPA container later. And now, let's move on to connecting our database with an SQL container. We have a database up and running. There are some views we are ready to populate with our data. How do we connect one with another? We already know about Vaadin data model. That's one thing needed in the process of allowing our awesome recipe book to read and save data. We need to connect our application to the database and tell it to translate the data into our model. This is why we are going to use SQL container. SQL container is part of Vaadin core and is the simplest way of talking with relational databases. It supports two modes depending on how advanced our database structure is. In most simple cases, and such is our recipe book, it is enough to use SQL container in table mode. What it means is that the tables in the database are translated into containers. Rows are thus items, and column value pair forms the property. The other mode, free query, is more sophisticated. It allows us to define our own SQL queries, which would be useful if our database used, for example, views to present data. The table mode has an implicit requirement. Each table in the database needs to have a version column. We need to be able to detect changes to the data done by another user from another session. For this reason, the value of that column must be automatically updated by the database, not by our application. We have not considered that column in our model. Let's update it to include the column with the default value of 1. One way to automatically increase this value is to create a trigger that will be fired before a row is updated. This may of course vary from one SQL database to another. Okay, enough theory. How do we instantiate SQL container and where do we do it? There are different ways. Let's hide the fact that we are using SQL container. In fact, our application should just care about the fact that there are 3 containers, not how exactly they were created. Let's create a container service interface with 3 methods: getUsers container, getRecipes container, and getComments container. We should also have some sort of a service provider, which will be able to give us an implementation of that service, so that we do not have to instantiate it manually every time. Our provider will have one method, getContainerService. Finally, let's make the provider singleton by hiding its constructor and providing a static method that will return a global instance of the provider. Now, we need a way of actually constructing the SQL container, but we already know where we will do it, in the implementation of our container service. And, of course, we will return that implementation in our service provider, just to give our application more flexibility if we ever decide to change our data accessing technique. Let's get going then. First, we need a JDBC connection pool. we need to pass parameters to the database. So let's specify the IP, database name, user, and password. Then we should create table query, specifying the table we want to access as a container, for example, users. Finally, we create an SQL container. Let's repeat that process also for recipes and comments. There is one more thing we need to consider: relations between tables. SQL container does not support it automatically. We must add them explicitly through add reference. Let's do so for the recipes and comments. Now, every time we need a container, we can access it by obtaining an instance of service provider and calling the proper method. What we have achieved is that the database part is completely transparent to the rest of our application. We could later switch to some other container implementation and it would still work. That's the main benefit of Vaadin data model. That's a lot of things we have done so far, but as a result, we have a working database and we are able to use it as a container in our code. Time to see if it really works. So far, our database is empty. Even if things work, we still couldn't see it. Let's add some data then. That's the topic of the next video. Previously, we have set up a database and created a service that will return us containers to work with our data. Time to do something with the data. We will start by preparing a registration form. Once the form is successfully filled in, we will save the data to the database, which will allow us to log in later on. Let's consider a bit what are the requirements for the users to register. First, we need the email address to be valid. Second, we need it to be unique. Finally, the password should be non-empty and the repetition of the password must match. Of course, all fields are required. Each field in Vaadin implements interface validatable and supports adding and removing validators. A validator simply checks that the value in the field is correct and defines what does it mean for a value to be correct. Most importantly, the validation takes place at the server, thus protecting our application from malicious code sent from the browser. As it should be with a good framework, Vaadin ships with a number of useful validators. Ensuring that the typed email address is correct is very simple. We just add email validator to the list of validators our email field has. One single straightforward line of code. While the email validator does not fully comply with the official email syntax, it should be good enough to cover 99% of all possible use cases. Let's move on to password validation. For security reasons, it should be no shorter than 6 characters and it should contain at least 1 letter and 1 digit. Unfortunately, there is no validator for that, so we have to write our own. But it's very simple. We just make an inline anonymous class that implements validator and implement our requirements there, like this. Next on our list is the requirement that the retyped password must match. This may clearly be a challenge as we do not store the retyped password anywhere. More than that, we don't want to store it. Fortunately, we can just compare the values in the components. Let's add another validator, but not to the original password field. Finally, all fields should be required. This is built-in functionality of every field. There is a method named setRequired. So let's just call it. One important thing we want to consider with respect to fields: buffering. Buffering means that the value entered in the field is not passed to the underlying container unless explicitly committed. The benefit is that we can always cancel what we changed since the last commit by calling rollback. In which case, the field will ignore our changes and restore the value as it is in the data source. Our container works the same way, which means that we have 2 levels of buffering. We just need to remember that when we commit the fields, we need to commit the data in the container as well, so that it gets saved to the database. What next? Well, time to actually connect the database with the fields. We will do that in the next video. We are almost done with this section. What we have done so far is that we have a database which we can connect to, and we have the fields that validate user input. We need one final thing: connect the fields with the underlying containers. For that, we will use field group. It is not a UI component. Rather, it is an object that connects UI components with properties. It is even capable of creating and binding fields for us, in case we do not have one already. Fortunately, we do. Let's go to our registration view and bind the existing fields with the data. When we create the view, we are creating the components. We could bind them to properties with field group at the same time. We do it simply by calling bind. There. When we enter the view, we should create a new empty user data so that we can edit it with the form. We do it by first obtaining our container and then adding a new item there. What we get as a result is an ID of the newly created item. Let's obtain the item then and set it as the data source for the field group. It will automatically assign values to bound properties. Finally, we should save the data. We can do it by adding a click listener to the button. To make life easier, let's make our view also a button click listener. In the listener method, we will check if the fields in the field group are valid, and if they are, we will commit the changes. We could also navigate to some other view so that the user does not register again, but that requires significant changes to our code. Let's leave that for later. We will only disable the button so that the user does not register twice. We will add some flavor to the registration as well. Let's show a notification that some fields are invalid. And then let's show a message that we have registered the user. When we commit the field group, which will send the data to the item, the container will save the data in the database. We just need to tell the container to work in auto-commit mode. In theory, our application should allow creating new users. Let's try it in practice. Right-click the project and run it on the server. We see the main view of our application and a button that will allow us to register. Let's click it. We see our form. Let's try to register now without typing anything. We get an error, which is good. Let's input some invalid data, for example, a misformed email address. Still, we cannot register. Okay, well, let's try with a mistyped password. Good. Our application does not allow us to continue. Finally, let's type in valid user data. Hooray! Works. Let's go to the database console and see if the data was actually added. It's there. It's possible that you may see some empty records here. That's because the new user data is created every time we enter the view. We would need to find a way to get rid of those records. We'll note it on our list of things to do later. So far so good. We have gone through the basics of database connectivity, field validation, and also we know how to bind our UI with our data. We will follow a similar pattern throughout the rest of the course whenever we need to do anything with data. As we have seen, it is quite simple and straightforward. Time to go on with our application. The next section will focus on styling and theming. To say the least, our views do not look appealing. Let's move on and make it a bit better. So far so good with our recipe book. We have database backend which we can connect to. We have built a number of views we can use. We are missing functionality and, well, our software looks ugly. This is something we will try to address during this section. We will learn how to style Vaadin applications, how to build custom themes, and what are the performance considerations. But first things first, let's start with the basics of styling and the organization of files. Vaadin is a framework for developing web applications, which means that whatever we code ends up in the browser window rendered as HTML. Therefore, we can style it using CSS as any other HTML page. CSS, Cascading Style Sheets, is a presentation language for markup languages. It has its own syntax based on selectors and rules. There are numerous tutorials and introductions to CSS available throughout the internet. We will go through the basics in the next video. The most important thing for us to know right now is the class selector, which is just a class name with dot in front of it. This way, we are able to reference style names we set for elements in Vaadin code and apply proper formatting to them. We have already discussed how to do it. Each UI component has a method addStyleName, which allows us to do exactly that. Pass a style name as its CSS class to the browser. Vaadin uses SAS, syntactically awesome style sheets. The syntax is almost identical to CSS, except that SAS allows more flexibility. Most importantly, nested rules and variables. SAS file gets compiled to CSS automatically by the framework. How to tell Vaadin to use our custom CSS file. By creating a theme, Vaadin plugin for Eclipse has an option to create a new Vaadin theme. When we do that, you can see that our main UI class has been annotated with the name of our theme, Recipe Book Theme. Some SCSS files have also been created in Web Content, Vaadin, Themes, Recipe Book Theme. You probably also noticed that the theme was created when we started developing a new application. A file into which we should put our style names is named recipebooktheme.scss. What are the other files? Well, styles.scss is an organizational file. This is the file that the framework looks for when the browser asks it for a stylesheet file. It contains two import statements, one for our stylesheet file, recipe book, and the other for add-ons. The latter is automatically managed by the framework and depends on, as the name implies, add-ons that we have added to our application. Are there any built-in styles? Of course, this is something we will cover in the next video. We have created a theme to our application. Currently it does nothing, as it is empty. In the other videos of this section, we will populate our theme and learn more about styling. At the same time, we will try to improve the looks of our application. In the previous video, we have created an SCSS theme for our application. As of now, the theme file is empty. In this video, we will go through the basics of CSS syntax and learn about basic built-in Vaadin themes. At the end of this video, we should improve the look of our application by a tiny little bit. Let's start with our theme file, recipebooktheme.scss. The first line in this file says, import the reindeer theme. Reindeer is one of the built-in themes and is enabled by default. It styles all of the core components in an elegant way. There is another built-in theme. It's called Runo. Let's replace all occurrences of reindeer into Runo and restart our application. Our application looks much different now. The buttons are rounder, the font is different, it looks more modern. We will keep this style as a basis for our future modifications. Let's start with the button that says Forgot Password. It should look more like a link rather than a button. We can style it to look like a link. Both built-in themes can be easily referenced from the code. Let's open our main UI class, which is where we define the look of our login form. The operation of making a button look like a link is very straightforward. Both built-in themes, Reindeer and Runo, have classes with constants that correspond to the commonly used styles. In both cases, the style for making a button look like a link is the same, button link. Let's add the style to the button and see what happens. That was easy, and it looks exactly as we wanted. However, most of the style changes are not that simple. Before we start improving the look of our application, let's learn a bit about SCSS and its syntax. An SCSS file lists optionally nested selectors and formatting rules. The selectors are the same as in CSS. The most commonly used one with Vaadin is the one for selecting elements based on the value of their class attribute. Formatting rules are put after the selectors in curly brackets. They have a form of an attribute, colon, and formatting. Let's try that in practice. We have just set the style of a button to look like a link. We can also set our own styles. Let's do something with the login form. The labels could use a different font weight, they could be bold. Their color could also be a bit more visible. Currently it's dark gray. Let's make it black. Let's first add a style to both components. Style names should be informative, so let's use visible form item. Now time for CSS. Color should be black, font weight should be bold. And of course this needs to be applied only to the caption of the form item. Hence the rule. Vaadin has rather self-explanatory class names. They are explained in great details in the book of Vaadin. Let's see how our code works in practice. Very well. Let's change something else. For example, in the login form, values entered by the user should be centered, not left aligned. We will probably use that style name later on to indicate that other components should be centered as well. We don't want to use string literals all over our code. Let's create a theme file that will hold constants for us. And then let's code on some styles. It is intuitive and self-evident, so writing styles for Vaadin application is quite easy to start with, and then it gets even easier with time. One final change. Let's change the behavior of all the buttons, so that when the user hovers a cursor over them, text becomes a bit darker, black, and underlined. This time we do not need a style name, as we want all buttons to be affected. There, ready. We have learned a lot during this short video, how to use CSS style names and where to put our formatting rules. Time to move on to the next video, where we learn a bit more about layouts and component sizing. We already know how to refer to components in CSS and do some styling based on that. Is there any other way we can influence the look of our components? Of course. Let's find out how to do it. Almost every component in Vaadin is sizable. What it means is that it can have a defined width or height, or both. Experience shows that it is usually better to size components using CSS, but at times it might be really frustrating or time-consuming to figure out a proper CSS selector. Hence, directly specifying the size of a component might be the only option. What is important in this context is the fact that the dimensions of a component will be rendered as an inline style in the corresponding HTML element. This means it will not be possible to override the size later on at all, using CSS of course. We can still modify the size through the code. All sizable components have also two utility methods which are very useful. setSizeUndefined clears any information about the width and height that is present in the code. Instead, the framework relies on CSS to determine the dimensions. setSizeFull sets the dimensions of a component to 100% times 100%, meaning that it will always take the entire space that is available to it. This method is equivalent to calling setWidth and setHeight separately, each time with a dimension of 100%. This means that it is impossible to change the size of that component to something else with CSS code. This method is especially useful when using grid, horizontal and vertical layouts. All these layouts arrange components in boxes, and the boxes are resized, not the components. It's best that we see this based on an example. Let's go to our settings view. It lists 3 buttons, one below the other. It would probably make more sense to have them lined up horizontally. Let's put them into a horizontal layout. That looks a bit better. The buttons are of different sizes though. That's the default behavior of the horizontal and vertical layout. Each component will take just the space that is needed. Let's change that to some fixed value, for example 450 pixels. The buttons are of the same size as previously, but the space between them has increased. This is because, as we already know, the box that displays the component was resized, not the component itself. Let's instruct the buttons to always take the full size that is available. A bit better, but the buttons are now very close to each other. We should add some spacing between them. Fortunately, horizontal and vertical layouts have a method named setSpacing, which sets the spacing on or off. The actual size of the spacing can be specified in CSS, but we should be okay with the default one. There, good enough. The best place to look for CSS style names is the book of Vaadin. This will be helpful to figure out, for example, what is the class of the element that defines spacing if we would want to change its dimensions. Not all of the layouts use the box-based approach. For example, the CSS layout does not. Let's see what happens when we size components there. Let's move on to our food view. It contains a tree, an image, a text area, and a table with comments. The last of these components should probably take an entire width of the page, so let's do so and see what happens. That's a nice effect. We suddenly can see the component exactly where it should be. Let's size also the remaining components, this time through CSS. It will enable us to float the image to the right, even though we will not be able to see it, because it's empty. Well, that's almost good. We still can't see anything from our tree, probably because its height is 0. Well, after setting it to 100% in the CSS, it's still not visible. That's due to the fact that there is no data for the component to display. We will go back to it later. One last thing to do. Our search view currently does not even indicate that there will be anything worth seeing later on. That is because it does not contain components. Let's put some mockup there, a table that will indicate results and a label that says there will be a configuration panel for search. We will replace them with real components later on. Nothing happened. How can that be? Let's inspect the page with Firebug. We can see that the main layout for the page is vertical layout. It takes minimal amount of space needed to display the components. Let's replace it with CSS layout and modify the top bar so that it has fixed height and takes the entire available width. Furthermore, let's increase the space available for showing our views. Let's make it full size. Also, let's improve at least one thing. Let's move the divider a bit more up and lock its position so that the end user cannot drag it. There. It looks nice. That should be enough for the basics about layouts. We have gone through some more advanced features of layouts, and we have improved the look of our application. A tiny little bit, but still. Well, lots of work ahead of us. Before we go to the next section, we will talk about performance issues with respect to layouts and how to monitor it. So far, we have gone through principles of layouting and component styling. The layouting is an important part in the process of developing an application. Not only it should be visually appealing, but it should also be fast. Different layouts have different performance. Vaadin offers a way of measuring and debugging the page that is currently displayed. In this video, we will learn how to get access to that information and how to use it to our advantage. The debug window has been completely redesigned in the recent releases of Vaadin. It can be accessed by adding question mark and debug after the address, but before the navigator options that start with hashbang. Let's try it out. When the page is reloaded, we can now see a debug window in the lower right corner. It contains a number of tabs and some icons. Hovering a cursor over an icon shows a hint. The rightmost button closes the debug mode. The one next to it minimizes it so that it does not occupy space. Finally, there is a menu that allows us to change debug's window font size, overlay mode, and the like. Let's examine the tabs then. The first tab lists message log. It is useful when we would want to examine what exactly happens. The most important information displayed after every page reload is the time that was spent on layouting and parsing response from the server. As it can be expected, more complicated layouts tend to show higher values there. As a general rule, layouts that need to perform some calculations to display components, like horizontal or vertical layout, tend to be slower than other layouts. The rule of thumb is, the more layouting is done through CSS styling, the faster it will load. Similarly, the more nested are the layouts one in another, the more time it will take to render. The second tab shows general information about our application. The most important knowledge we may get from it is the version of Vaadin we are using. It may be that during the development of our software, a new version is released. In that case, we need to recompile the widget set, an option available from the Vaadin plugin to Eclipse. This will make sure that our client-side code that runs inside the browser is compatible with the server-side code that we have on our web server. The third tab contains some very useful utilities and consists of 4 separate tools. We can inspect something called the connector hierarchy tree, that is, the components we can see on the page. Then we can show details about a particular component shown. Let's examine the login button. We can see that the debug window now lists the properties of the button that are available to the browser, including width, height, primary style name, and the like. The third tool can be used to show potential problems with layouts. Fortunately, our application does not have any. The last tool can be used to optimize widget set. This is a very advanced topic and thus we will not cover it in this course. More information can be found on Vaadin forums. The final tab contains another view of the message log, this time limited only to the communication between the browser and the server. Let's click the login button. We should see a notification and another entry on the communications tab. We can examine the details of the message that was sent by the server in response to us clicking the button. That's it. We have gone through the debug window and now we should be able to troubleshoot potential problems. We can also use it to benchmark different layouts in terms of performance, as well as find potential problems with layouting. Finally, we can inspect the communication between the client and the server to debug what happens behind the scenes of a Vaadin application. That's enough information. We should get back to coding. In the next video, we will start implementing some meaningful code. We will start with logging in. Let's move on. Welcome back to the course on developing a web application with Vaadin. So far, we have developed most of the non-functional requirements, divided our application in views and created a service provider through which we can obtain container with data. We have also done some styling and layouting. Time to do a bit more. Let's make use of our application and start implementing some real functionality. Let's start with logging in. During that, we will learn how to store and clear session information and how to filter containers. We already have a stub for logging in, but it displays a dull notification and does nothing else. On the other hand, we already have a working registration form, which means that the most logical next step is to enable logging in. Let's do so. How do we proceed? Well, in the code responsible for logging in, we could obtain an instance of a container with users and check if there is an entry that corresponds to credentials. It is a very straightforward solution and, as such, it will work. However, it will pollute our UI code with details concerning the structure of the user's container, the way it should be filtered, and the like. The solution is, as you probably guessed, another service in which we encapsulate the implementation details. The UI will just get the service through the provider and ask it to perform logging in. Let's create login service interface with a method named login that takes email and password as strings and returns true or false depending on whether or not the operation was successful. Let's also create a reference implementation of that service and update our service provider to have our login service available. Since checking credentials requires a container, we should somehow let our reference implementation know how to obtain one. We can do it by just passing an instance of that service during construction time, so that the service implementation can get the container when it needs it. This way, we can also later change our database backend, and our service for logging in would still work, provided that we keep the containers unchanged, of course. One final thing. How do we check credentials? The simplest way is to add filters to the container and then see if there are any items left. Not all containers allow adding filters, only those that implement container filterable. For other containers, we can just iterate over the contents and return true when we find a matching entry. With that knowledge in mind, time to code. Alright, it's there. Let's make use of it for now. And just display a notification with results. It seems to work. Great. However, we can log in an infinite number of times and no UI gets updated. We should do something about it. We should replace the login form with a component that holds a button for logging out and repeat that pattern when the button gets clicked. Let's do it based on events. Our login service should broadcast login events in addition to returning true or false. We will need some information about the user that is currently logged in. Let's store it in the login service. Since we are using Vaadin data model, we can return an item that will hold the data, or we can create a user class out of the item. Let's choose the latter option, as it gives us more flexibility if we ever decide to change things. That's a lot of coding, but let's do it. There, seems to work when we log in. It also works when we log out. Let's log in and switch to another view. Well, good. How about page reloads? Oops, that's not what we expected. How do we make our application remember that the user has logged in? That's the topic of the next video. So here we are in the middle of developing our recipe book. We have the styles, the views, and the working login button. Well, somewhat. We have discovered that the user can log in, but that information is lost between page reloads. We should do something about it. The majority of web applications face exactly the same problem, and that is because of the statelessness of the HTTP protocol. The solution is very simple. We can store session information on the server side. The Vaadin framework uniquely identifies each session of our application and allows storing any data only for that connection. This is exactly what we want to achieve. Naturally, we would not want one logged-in user to affect the actions of another user. Vaadin session is a class responsible for storing session-specific information within the framework. The session is available in any UI class through getSession. As we already learned, we can get the current UI through a static method. There are two ways of storing information in the session class, by attribute name and by its type. As we now know how to store session information, we should find the best place to write the session-related logic. The best candidate seems to be the login service. Whenever we log in, we should store current user as session data, and when we log out, we should remove that information. Vaadin session will also allow us to remove the private field we used to store currently logged in user. Anyway, let's code our solution. Okay, great. Now we should somehow make sure that the login form is not displayed when we are logged in. We need our login service to provide the data about the currently logged in user. The data is already stored there, so no problem in just modifying a getter method to include that. There. Okay, now on to the main UI class to code the form hiding logic. Let's try it in practice. That works pretty well. Let's try and reload our page. It will make a new request, but the session will stay the same. It means that the information about the currently logged in user will be preserved, and this is indeed the case. That was an important part of the work we did in this video. We have learned one of the most important things in the development of a Vaadin web application: how to access and store session data. With this in place, we can go forward. One view of our application, namely the settings view, should be displayed only to the logged in users. In the next video, we will learn how to prevent a view from being displayed until a condition is true. But before we move on, there is one thing we should fix in our application. Our logging in service is event-based, but the operation responsible for logging in is still returning true or false. Let's modify that part of the service. We will add a new method in our listeners called logging failed, and modify our code to display a notification in response to that. This way, our login service will be fully event-based. Let's code that and move on to the next video. From the functional point of view, our application looks quite advanced. We have a registration form that works. We can log in and store the current user data in the session so that the user stays logged in between page reloads. As always, there is room for improvement. For example, now we can navigate to the settings view even when we are not logged in, and to the registration view when we are. This is obviously wrong. Let's correct that. In this and the next video, we will learn about view events and how to use them. You should remember that a Vaadin view registered with a navigator should implement a method enter. That method takes one parameter, viewChangeEvent. One particular method of the event, getNavigator, gives access to the navigator that triggered the view change. This means that within any view we can get an instance of a navigator and use it to navigate to somewhere else. This method alone is enough to implement the behavior that we are interested in, preventing a view from being displayed until a condition is true. Though, to say the truth, it will allow us to navigate to somewhere else as soon as we enter the view we do not want to show. Let's implement it this way and see if we can improve it later. Our requirements are to prevent showing registration when the user is already logged in, and prevent settings view when the user is not. We can make it so that we redirect from one of those views to another depending on the situation. And while we are coding, we will discover that our settings view is actually not displaying any data because the components are not assigned to a data source. We will implement that a bit later. For now, let's just leave it as it is. Let's see if what we have written so far works. It does. We cannot access the registration view when we are logged in. Neither we can get into settings view when we are logged out. That's good. The problem begins when we log out while being on the settings view. Fortunately, our login service is event-based. Let's just listen to the events related to logging in, and we should be fine. Let's trigger page reloading whenever appropriate, and that should work. But how to do that? Well, we cannot force the UI to be reloaded, but we can reload the whole page instead. In our case, the end result is exactly the same, as there is one UI per page. Vaadin's UI class contains a reference to a page, which has a method reload, and we already know that it is possible to get the current UI through a static method. Let's use that. As it is just now, it will not work. Every time we ask service provider for a login service, we are getting a new instance of it. Let's change it so that the service provider keeps a current instance of a login service. And now it works perfectly. Well done! That's enough new things for this video. We have done two very important things. We learned how to use view events and redirect application to another view when we do not want to display a certain view. We have also found a way to reload the currently displayed page. In the next video, we will learn how to pass parameters to views. In other words, we will begin implementing a stub for our search view. Let's move on. The development of our recipe book is progressing pretty well. So far, we support registration and have fully functional logging in and out. Just recently, we have implemented preventing a view from being displayed when a certain condition is true. We used one method from ViewChangeListener, and there are more. In this video, we will learn how to pass parameters to views. We will need that to fully support our search view, which we have not yet implemented at all. Let's move on and get started from our search view and its enter method. More precisely, let's examine the API of the ViewChange event again. We can find a method named getParameters, which returns a string. This means we will have to find a way to divide this parameter string into a number of options relevant to our search. Let's focus on that for a moment. We should be able to query our recipe container for recipes written by a given person, or by tags, or by title, or by ingredient. That's 4 parameters. The parameter string is what is passed to the navigator, right after the view name and the slash. Since we are free to decide what is the allowed syntax for our parameters, let's just use something human readable. So, for our parameter string, let's use attribute value pairs divided with slashes. We can then convert the parameters to container filters to display the results that match the criteria. The parameters are a part of a navigation state, so they are bookmarkable. It would be good to have a URL that indicates what it points to. Let's consider where to place that code. Polluting our search view with logic specific to the structure of a container is a bit unfortunate. Let's instead put it in a service. Container service seems like a good place. We can specify a method that will take a map of parameters and give us a container with the results. Let's do some coding then. We will start by dividing the parameter string into pairs of attributes and values. Based on those pairs, we will construct filters that we apply to containers. Multiple attributes mean that all of the conditions should be satisfied. Of course, we could write more advanced queries, but let's start with something simple. Let's implement filtering by users first, as it is probably the most complicated filter. Let's code. We will need to first find a user or users whose name or email address is similar to the queried value. Once we do this, we will search those recipes that are written by one of those users. If there are no such users, we will return no recipes, obviously. And while we are coding, we will also refactor our logging in logic to use filtering in the container service rather than login service. This will reduce duplicated code and allow us to have unified container filtering in our application. Well, that was a lot of coding. Fortunately, the other attributes require less work, as they can be directly queried from the recipes table. Let's start with title. When we search for recipes titled pancake, we of course would like to find all recipes that contain that word, not only title pancake. We will use the filter like for that. Let's add it. Well, that was simple. Let's use a similar approach with the like operator for tags and ingredients. While it is not perfect, it will find eggplants when we would look for eggs. It should be sufficient for the needs of our application. We should just first divide the tags and ingredients parameter into lists. And for each element of that list, we will add a filter. This will allow us to search recipes based on more than one ingredient or tag. We are done for this video. We have implemented searching, we learned how to read parameters passed to navigation view, and we improved the design of our container service. In the next video, we will implement the other end of what we have just done. We will populate our search view with components and start searching and displaying results. Let's move on. We are getting close to finishing this section. So far we have learned how to query containers, store session data, and react to view change events. We also know how to read parameters passed to each view. In this final video of the section, we will learn how to pass parameters to the view. We will focus on our search view. This is the only view that has not yet been implemented, aside from a few placeholder components. While the table looks okay for now, we will configure it later, the search panel is completely missing. As of now, we would not be able to really test if our search panel works, because we have no recipes in our database. This is something we will cover in the next section. However, we can still implement everything related to searching. We will just test it when we have something in our database. Let's get going. Our search panel should have 4 components. We need to be able to specify author of a recipe, its title, one or more of ingredients and tags. Let's start with users. It will be enough to provide a simple text field in which we enter user's name. A similar component will work for recipe title as well. Let's do that. Another thing we are going to need is 2 buttons, one for submitting the form and another one for clearing it. The latter is simple to implement, so let's do that. Actually, let's create a method in our view that will clear the form, and let our buttons listener call it. Okay, now time for the button that sends the query. Since we already implemented activating query when we navigate to our view, let's use that. Let's prepare search parameters and navigate there. We need a navigator for that. Fortunately, we can get one when we enter the view, so we can store it as a private field. Let's code then. And let's try our code. Looks good. When we enter search criteria, we get redirected to a proper address. However, our search parameters are now gone. Let's make them show up in the components before we implement the remaining 2 fields. That should do the trick. What should we do about the other 2 components? Our parameter parsing expects it to be a list of comma-separated values. Well, for now we can just use a regular text fields and simply remove all whitespace around commas. Anyway, it seems that we might need a dedicated component for that. Maybe this is something we will do later. For now, let's just use the text field and modify their values when we submit the form. Let's keep coding. And let's see if it works. Apparently it does. The search view, though, has gotten a bit ugly. Let's put the components into two columns. A grid layout will probably work best here. A bit better. Now that we know how to fix these kind of layout problems by using CSS, fixing that won't be an issue. We will do it later, when everything else is done. That's all we had to go through in this video. We have learned how to initiate views and pass parameters to them. It was a very valuable lesson, which will come in handy a bit later. Our search view seems to be working, except that it does not search at all, because we have no data. Let's focus on that in the next section. Time to add some data to our application and learn how to upload files, run threads, and initiate server to client messages. Let's go! Hello and welcome to section number 6. Our application, from the functional point of view, is getting more and more advanced. Just recently we have coded our search view, allowing us to query our database for recipes. Of course, it does not work because we have no recipes. This whole section will be us trying to fix that issue and allow us adding new recipes to our database. Our settings view contains a button that is expected to show us our recipes. Let's add another one that allows us adding new recipe. We already have a recipe container and a view for recipes. We also know how to pass parameters from one view to another. Let's make it so that by clicking Add New Recipe, a stub of a recipe will be created, and we will redirect to the food view showing that recipe. Based on what we have learned so far, it shouldn't be too difficult. Let's go. We need a way of creating new recipe and populating it with default data. Let's use the container service for that, as it knows the most about the underlying data structure. We will also need to pass data of a currently logged in user, so that we can already bind the recipe with its author at the moment we are creating it. Our logging service keeps this information in its internal format. We will need to query our container service to find the ID. We can set the value of another field in our recipe entity as well, the date the recipe was created. Let's use the current date. Oh, and let's set up a default title for our recipe too. Once we have added the recipe to our database, we should show it. Let's redirect to a recipe view, and let's pass recipe's ID as a parameter. Great! Now we need to make sure that our recipe view, or food view, is capable of reading the parameter and displaying a proper recipe. We shall also make it so that when a recipe is shown to its author, that is, the currently logged in user wrote the recipe, it will show in edit mode. That means that certain components will be different than what originally planned. For example, the title of the recipe, or the instructions, or the ingredients should be editable when shown to the author. Let's move the creating and adding of components to the layout away from the constructor, and let's do so when we enter the view. Let's also ignore file uploading just for a moment. We will get back to it in a second. That's a lot of coding again. Let's see if it works. That looks somewhat okay. We can definitely improve the look and feel just by adding captions to the components. We are also missing a button to save changes. Let's add it at the same time. Okay, it seems to work. Now, what about that file upload? A component that supports file uploads is named, amazingly, upload. Unfortunately, it's not a field, meaning that we have to do some work in order for the information to be correctly stored in a database. Our entity is expected to store a file name rather than the file directly. Seems that the only choice is to upload a file, store it in some location on the server, and let our entity know about the location of that file through a text field. Sounds like a plan. Before we start coding, let's take a look at the API of an upload component. The constructor accepts a caption and an upload receiver. The latter is what will be notified when the upload starts. A method receiveUpload will be called, and it is expected to return an output stream. So we can safely create a file stream, and our upload component will write contents there. Okay, but how do we know about when the upload is finished? Upload component broadcasts a whole bunch of events, one of them at finishing the upload. We could use it to assign the uploaded file name to our entity. For that, let's create a hidden field into which we store the file name. And let's update our entity to have that column as well, because it seems we have missed it. That's it. Let's see if it works. Our upload component is here. And it seems to work. Great. That's an important feature we have added to our application. Uploading files is essentially needed in every web application. Now that we have the file upload done, let's focus on displaying it on screen. Naturally, we would like to see what we have uploaded. That's the topic of the next video. Let's move on. We have just implemented the functionality of uploading files. We know that it works. Our application successfully saves the file to the disk and updates our recipe. The logical next step is, of course, displaying the uploaded file. This is something we will learn in this video. The component to display images is, as we already know, image. The relevant API consists of methods for setting two properties, source and alternate text. The source of an image is a resource. This is an interface for referencing any content that is something external to our application. There are 5 subclasses, one for each type of resource available. For our current needs, file resource sounds like a way to go. We simply want to refer to a file from a server file system. Let's see if it works as expected. When we upload the file, we save the recipe automatically. Let's show the image at the same time. Okay, great. That seems to work, and it was much simpler than anticipated. Let's modify the food view so that the image is automatically loaded as well, because currently it is loaded only when we upload it. Okay, great. We now know how to upload files to our application and how to store them on the server side. Moreover, we have learned how to access those files through file resource. Still, A lot of topics ahead of us. Before we move on to another video, we definitely need to clean up our code. There is too much redundant code in our food view, and it is polluted with details regarding how to store files. Let's move that part away to a dedicated service. It will contain one method that would return a file for a given file name. Let's also add a button that allows the author to preview the recipe in read-only mode and back. Let's also make it so that whenever we log in while being in a food view, the button for switching modes will appear if the logged in user is the author of the recipe. Oh, and one more thing. We should have a button for clearing the uploaded file. We will also need to add a corresponding method to our file service. Lots of coding again, but let's go. There we have it. Our application now supports uploading files. It even displays them properly. Perfect. Now we are ready to go to the next video, where we will learn how to do server-side processing of images in a separate. Now that our application supports file uploads, we should somehow ensure that the files are indeed images. We could also make sure that the size of an uploaded image is not too large. Of course, we could ask our users not to upload images above a certain size, but we can ensure that on the server side. This means that when we get the file from the user, we should check if the dimensions are bigger than what we allow, and if so, we should resize the file before it gets saved. Resizing the image is an operation that can take some time, and we most likely do not want our users to wait while it is being done. Instead, we should process the image in the background so that the users can use the software in the meantime. Once we receive the file from the user, we should first check if it's an image file, and then resize it if needed. Only when the uploaded file has been successfully resized, we should modify the entity, otherwise we should just show an error message. Let's start then by implementing our solution without threads. Oh, and one more thing. Since image resizing is not a straightforward thing to do in Java, we will use ImageMagick with its Java command line wrapper, IM for Java. Our code will be thus cleaner. Of course, it requires our deployment system to have ImageMagick available. Let's download everything before we start coding. And now let's code image resizing. The code flow is currently as follows. Upload finished listener calls image processing, and once this is done, it broadcasts an event, which we listen to in our food view to update the displayed image. Let's try it in practice. It works when we upload an image. What would happen if resizing took a bit more? Let's find out. Let's artificially increase the time our service needs for resizing the image by delaying it. Our application seems to be frozen. It does not react to anything. We should definitely do something about it. Let's run the image processing in a separate thread. However, in order to have everything under control, we should have a central point through which we access threads, so that we can clean them up when our application is terminated abnormally or when the session of the user times out. Of course, we will have a thread service. And in our UI class, we will add a session destroy listener so that we stop all the threads that were run by the current user. Okay, that looks a bit better. The application now allows the user to do other things while it's processing the image. That's good. The main problem is that we are not notified about the result of an operation until we actually do something that makes a request to the server. Fortunately, the next video will contain a simple and powerful solution. Let's move on. Our recipe book looks like a real web application now. We have just added a possibility for uploading files and implemented server-side image processing that happens in a separate thread. Those features bring us to the topic of this video: how to show progress of an operation that is happening on the server, and how to show progress of file upload. These questions are not irrelevant. They allow us to create more responsive and user-friendly graphical user interface, which greatly improves the usability of our software. Let's start with file upload. As we already know, there is a significant number of events that the upload component broadcasts. Aside from events that are triggered upon transfer completion or interruption, there is one broadcasted while the file is being uploaded. That covers one part of our solution. We now should find a proper component to display the progress of file upload. Naturally, we can use a label with some pre-formatted text, but fortunately, Vaadin offers a built-in component to display progress information. In fact, there are at least two such components, progress indicator and progress bar. They are identical in the sense of look and feel, and both display progress as a floating point number from 0 to 1. Progress indicator repeatedly asks the server every second about the status of an operation, and you may see in the Java doc that it is deprecated in favor of progress bar. Let's not use the deprecated component, but progress bar instead. We will of course hide this component once there is nothing more to update, that is, when the upload is finished, interrupted, or otherwise failed. That means we have to modify our existing upload listeners and add some new ones. After we set up our listeners, we need to instruct our UI to poll the server every now and then to update the component change. Otherwise, changes will be queued on the server side and sent to the browser at once, at the nearest occasion. That is, when the file is uploaded. Okay, we're ready. Since our deployment and development machines are the same, uploading a file will be really quick, unless we upload a really huge file. Let's do so, and let's choose a non-image file for that, so we can see how our application handles erroneous situations. Okay, that seems to work really good. The file gets uploaded, and we see the progress bar. But then there is something that we can improve. We see no other things happening until the processing is over, which results in a message. We should somehow indicate to the user that the upload finished and image resizing takes place. We already have all events we need available. We used our upload progress bar in determined mode, meaning that it has a concrete fixed value to show. Let's use that component in undetermined mode, meaning that it will be showing a looped animation that signals a background thread working. Once the thread is done, we can hide the component. Let's code. Alrighty, seems that everything is in order, and it was not that difficult, thanks to built-in features of the Vaadin framework. We have learned how to display progress of a file upload, and how to use a component that polls the server every now and then to check for a progress of an operation. The problem is the polling. This is a bit resource consuming. Every time we need to make a request, the server needs to process it and send the response. In the next video, we will address this issue by using push, a server-initiated technique of sending data to the browser. Let's go on. Our recipe book looks more and more amazing with each iteration. The recent addition of a file upload, together with its background processing, works really nicely. We used polling to repeatedly send requests from the browser to the server so that we keep the UI up to date. This has at least two drawbacks. First, wasting resources. Second, we do not get the changes immediately. Only at times we send our polling request. Is there something we can do to make it better? There is, of course. Recent versions of Vaadin ship with a built-in support for push, server-initiated communication. This technique is implemented so that if a browser does not support it, it automatically falls back to polling. How do we use push? In two steps. First, we need to annotate our UI with push. We will also specify its mode to be manual. By default, push is automatic. We do not want to run it all the time. We need only one view, and we will invoke it when we need it. Second, wherever we want to send the data to the browser, we should call UI.push. This will send all the data queued at the server to the browser. Let's try that in our food view. We should switch off polling and replace it with push whenever something happens, that is. It means that whenever UI components need to be updated in response to our events, we should call that method. Let's code. Everything should now be in place. Let's try it out. That's success. We have push working, which concludes this video. Fortunately, many things are this simple with Vaadin. We have just replaced repeated server polling with a more advanced and resource-friendly technique, server push. It did require us to set up certain things, but the end result is worth it. During our development in this section, we have left out one component from the food view. It's the ingredients list in the non-editable mode. This is supposed to be a tree, but our ingredients list is a freeform text. We need to add support for this new functionality to an existing component. Among many other things, this is something we will do in the next section. See you there! Our application is almost complete. We are left with just a few bits and pieces here and there. And of course, lots of optimization and tests, but that's a different story. We left the last section while wondering how to display our ingredients list in a tree so that it looks structured. Vaadin is a framework, meaning that it includes a huge number of components for the majority of typical use cases. What's even better, it allows us to extend the existing functionality by adding new code to it. Let's take a look at the class hierarchy. We can see that every UI component implements adequately named interface component. Other important interface is field, which is used in those components that present some value to the user and allow it to be changed. To make adding new components easier, Vaadin includes a number of pre-made base classes, like custom component or custom field. These classes implement most of the functionality defined by the corresponding interface, while allowing us to focus on just adding new code. Simple and brilliant. Let's take a look at our use case again. We have a pre-formatted text which we want to display in a tree. That means we want to have a string field that is represented by a tree. The base class for us is thus custom field. Extending an existing component in Vaadin does not differ at all from extending any other Java class. We simply create a new class, specify a base class, and let Eclipse give us a skeleton implementation of missing methods. Field interface requires us to provide a type of the data it stores. In our case, this will be string. Let's do some coding. Apart from the missing method initContent, we should also override setInternalValue to update the tree accordingly. Then we just fill in the details. In this case, the details are conversion from a string to a hierarchical container. Since we disallow any editing, we do not have to care about the conversion from the container data to string. And now let's see if this works as expected. Well, just great! That was a simple lesson, wasn't it? As long as we are extending server-side components, it rarely gets any more complicated than just writing the new functionality. The important thing to remember is the subclass custom field when our component stores a value of some type, and subclass custom component in the vast majority of other cases. Let's move on. The next video will focus on creating a new component from scratch. Extending an existing component was an easy lesson we have just learned in the previous video. Sometimes, however, there is a need for a more sophisticated component than just a combination of already existing ones. Did you notice what is missing from our full view? We have title, ingredients, instructions, we even have a picture. Where are the tags displayed? They aren't. We should list them somewhere. They should also be a bit interactive. When a user clicks on a tag, they should go to a search view that lists all the recipes with that tag. What we could do is that we create a separate button for each tag and assign a button click listener to each button. But that feels a bit unproductive. It would be really difficult to reuse that logic in another software. Let's create a new component for this purpose. How should it look like? That's a good question. In general, it should be a field of type string because that is what we have in the entity. We should be able to specify a separator between the different tags. We should also support clicking the tags, but our component should broadcast one event with the clicked tag in it. It looks like we have to implement a Vaadin widget. This is a component that contains both a server-side code and a client-side code, with a defined state and a communication channel between server and client. Vaadin plugin to Eclipse allows us to create simple widget effortlessly. We can just focus on implementing what we really need from the widget. Let's start building our tag field. The plugin will create a directory structure for us, together with a number of files. The server-side part is just the tag field class. Client-side code contains a bit more files, of which the most important ones are the shared state, the connector, and the widget itself. The shared state is what the server-side uses to transfer information about the state to the browser. Both client and server files have access to it. We will cover the other files in the next video. Let's try and define the state of our widget. We definitely need tags there. To simplify our code, we can have the server-side component split the tags into separate strings and then have the client-side already operate on those. This means that the list of tags is the only thing we will put in our shared state. Now we need to modify the client-side files because of the changes in the state. Let's not focus on the client-side code too much yet. As our client-side widget extends a label, let's just set it text to the values of all tags combined. For now. Time to work a bit on the server-side part. We want a bit more functionality there, like defining a separator between the tags. We should also allow getters and setters for each individual tag, along with the method that returns the number of current tags. Since the list of tags is stored in a shared state, we do not have to keep it again in a component. The question we will inevitably have to ask is how to tell the widget that the state of a component has changed. Vaadin introduces a concept of a dirty component. When a component is dirty, it needs to be repainted by the browser. Naturally, there is a method named straightforwardly, mark as dirty. Let's call it whenever we modify the shared state. Okay, let's try that out. Let's open our food view and include a tag list somewhere. And run our application. And what's that? The browser complains about not being able to load a widget set. What does this mean? The answer is simple. The browser cannot find the client-side widget of our tag field. We need to compile the widget set for our application. That is, we have to create a file that contains our client-side code. Fortunately, Vaadin plugin to Eclipse makes that really easy. There is a button on the toolbar dedicated to compiling widget sets. We click it, and then we can go and have a break, as the compilation will take time, depending on the processing power of our computer. We would need to recompile the widget set again when we modify our client-side code. This code is loaded by the browser once during each session. It contains JavaScript code related to our component. In other words, any client-side Java code, widget and connector, among other things, gets compiled into JavaScript that the browser executes. Once the compilation is done, let's try our application again. Voila! Naturally, it does not look nice at all, but it seems that the server-side part is working, which is good. We will improve the client-side code in the next video. Here, we have just created a scaffold code using a Vaadin plugin to Eclipse. We have modified our server-side component to have the functionality we need, and we learned how to compile widget sets and why it is needed. But still, we are just halfway through developing a completely new Vaadin widget. Let's go on to the next part. Here we are, almost done with developing our Vaadin application recipe book, and about halfway in the process of developing an add-on we need to display tags or recipes. So far we have done mostly the server-side component. This time we will focus on developing the client-side widget and broadcasting events. Let's start with the tag field widget class, as this is what gets rendered to the browser. Currently it extends label, but we can use any widget available in width, similarly as we did when we extended the server-side component. Our tag component should look like a collection of buttons, one per tag. They should be arranged one next to another in a horizontal manner. Hence, we need to extend from a horizontal panel. Note that this time we operate on with widgets rather than server-side Vaadin components. Once everything is in place, we need to capture events sent by the buttons and translate those to an event that we will send to the server. How do we communicate anything from the browser to the server? Vaadin provides a communication channel with the help of RPC, remote procedure calls. There is an interface for server functionality the browser widget has access to, and vice versa. The framework handles all the low-level communication serializations of requests and responses and the like, meaning that we just have to define proper methods in RPC interfaces and we are good to use them. We will only need communication from widget to the server-side component, as everything else related to our code is handled through the shared state. Let's have our server RPC have one method that we will call, and include a clicked tag name there. Once the server-side component receives the click, it should probably broadcast some event to all other components that might be interested in it. Let's create code for that. Nearly identical code needs to be written for the client side as well. We have to capture the events broadcasted by the buttons in the widget and translate those to server RPC calls in the connector. This way, the server-side component will be informed about clicking a tag, and it will broadcast server-side events. With everything in place, time for us to recompile a widget set and try it out in practice. Let's add a tag click listener to tag field in our food view. We will redirect to a search view with that tag as a parameter. To be honest, it looks like we could abstract the navigation to a separate service. Let's put that on a to-do list and maybe do it later. Okay, all ready. Let's run our recipe book. And that seems to work really nice. That was an important lesson we have learned. Let's recapture it. Creating custom widgets is an important and useful skill when developing applications with Vaadin. Widget is what is displayed to the user in the browser. Connector is what captures important events that happen to the widget and communicates them to the server component. It is also responsible for updating the widget based on a state. Server RPC is what the connector is using for communication. It tells what methods are available for it to call. Component is a server-side code that can be called by the connector in a manner just described. When its RPC methods are invoked, it performs some actions. Other actions may cause the state of the component to be changed, which is what the shared state is used for. Any changes to the shared state are sent to the connector, and this connector updates the widget. This cycle shows how a communication between server-side component and client-side widget is done. Every single component in Vaadin works this way. Enough theory. We have just built our first widget. It was not that hard, and probably other users of the framework have created their widgets as well. Is there a place where we can share widgets? Of course. That's the topic of the next video, so let's move on. The development of our recipe book just saw us extending our first Vaadin component and building our first Vaadin widget. Naturally, the framework cannot provide all the components for all the possible use cases. That is why it provides a way for us to extend what is already there. There is also a collection of third-party add-ons and extensions to our frameworks that we can use. The functionality of our recipe book is almost complete. Almost. We have a way of adding new recipes and editing them. We can also register new users and even upload pictures to our application. Now, let's focus on commenting. We shall enable commenting for the registered users. Our comment entity requires a valid user, a recipe the comment deals with, and allows us to specify comment body and a rating of a recipe. The rating is a bit problematic part. What component shall we use? Our entity expects it to be a number, but it feels awkward to force our users to type a number. It seems more correct to have a custom component that displays the rating in a bit friendlier manner. On the other hand, it feels very repetitive. Probably someone somewhere already needed a similar component. Fortunately, there is a repository of add-ons to Vaadin. Vaadin directory. Not only it allows downloading what other users have already created, but enables us to publish our own work. But let's focus on finding a suitable component for our rating. We probably should search something related to rating. Rating stars. This looks like this could be useful. There is even an online demo. Yeah, that's definitely the functionality we want. Let's take a look at the documentation the developer provided. It says here that the component is based on field, which means we can probably use it as it is, without modification. Just great. Let's download the add-on and place it in the webinflip folder. This way it will automatically become available to our application. We also need to recompile widget sets, as the add-on may have a custom client-side code that needs to be available to the browser. What then? Well, since the add-on has just become part of our application, we can use it as we would use any other component. So let's build a comment form and include it there. Due to the lack of space in our food view, let's create the form in a pop-up. We will put all the necessary fields there and save the comment upon button click. And let's try it out. That's amazing. However, comments table did not get updated, probably because we have not yet assigned it to a data source. So let's quickly fix that. And try it out again. Amazing, just amazing. Adding comments seems to work. We should do something with table formatting, of course. Let's put it on our to-do list. As far as this video goes, we have reached our goal. We have successfully downloaded and integrated a Vaadin add-on from the directory to our application. And it was very simple and straightforward. We just downloaded the file into WebInFlip and compiled widgets. The add-on is available to the rest of our application without any special further considerations. Brilliant! Naturally, it is possible to share any of our own creations. Just visit vaadin.com/directory/help for more information about it. We are mostly done with our application, at least from the functionality perspective. Let's move on to the next video where we will go through a list of small but important things still left. Until then, the development of our recipe book is almost done. At least functionality-wise, we need no other major features. We should just run our application and see if there is anything we would like to optimize and polish. First, let's go through what we have done so far, so that we know what we have learned. We started our journey of developing a Vaadin application by setting up Eclipse, our development environment of choice, and learning about Vaadin components. When our setup was complete and we knew what the framework offers, we went through defining requirements for our application. We then proceeded to dividing our application into smaller, manageable pieces, views. We learned the purpose of layouts and how to use the navigator. With the basic elements in place, we developed a backend for storing data. We went through the details of a Vaadin data model, and we have found a way of validating user input. Having done that, we went through the look and feel of our application. To be honest, this is something our application is still terrible at. It just looks horrible, but at least we have learned the ways of improving the looks of our software, through themes and style names. We then moved on to more advanced features of web application development. Most importantly, we learned how to store data between browser requests by using sessions. Also, we went through querying containers and advanced features of navigation, like passing parameters to views. Another part of our development process was centered around file uploading and other time-consuming operations. We went through principles of running background threads, and we learned how to enable server-initiated communication to the browser. The final lessons we had dealt with building and using custom components. Not only we found a way of extending the functionality that is already provided by the framework, but also how to build a completely new component with both the server and client-side code. Lastly, we integrated an add-on from the Vaadin directory. Which brings us to the point where our recipe book is done from the functional point of view. We have some shortcomings and missing bits and pieces, but the majority of the code is up and running. Let's see what can be improved, apart from the obvious theme and styling. The most important thing on the food screen, table with comments, could be styled differently. We need less properties there, and we definitely want to show the user's name or email rather than entity ID. The former can be tweaked by just passing the list of visible columns to the table. The latter requires a custom column generator. Both are simple to implement, so fixing those shortcomings will not be a problem. Let's move on to registration view. Those nulls here are a bit scary. Fortunately, text fields have a property called null representation. By default, it is a literal null, but we can change it to be an empty string. Of course, a better solution in most of the cases is to get rid of nulls, that is, initialize the object with correct values like empty strings. While looking at the code, we will also see that a new item is added to the container every time we open a form. We can fix it by delaying the addition of a new item to the moment when the registration button is clicked. In the settings view, which is accessible only when the registered user is using our application, the button for showing recipes does not work. Solution is simple. Navigate to the search view with proper parameters. Navigation itself could also use some fine-tuning. Currently, in every view, we explicitly have to navigate to somewhere else. Instead, let's move navigation to a separate service which we can then call. Lastly, search results table could use some reworking. It has the same problems as the comments table in the food view. There is too many columns and the author name is not displayed. Also, the table is not clickable, meaning it is impossible to see the recipe we are interested in. Lastly, when the search form is empty, no results are found. Whew, that's a long list of bugs, and those are only the ones we have noticed on our first run. Fortunately, they are not that severe, and fixing them should be very easy. After all, we have developed quite an application with Vaadin, and during that process we have learned more than it is needed to address those issues. Our development journey ends here. I hope you have enjoyed the ride and learned how to develop web applications with Vaadin. The next videos will show you some extras the framework has to offer. But those extras are just an addition to a solid base of knowledge we, hopefully, gained during the videos. Thank you for watching. Our recipe book is more or less complete in terms of functionality, but it lacks implementation of one important feature. It doesn't send emails, which of course would be very handy when registering new users or when sending forgotten passwords. Vaadin framework is focused on web application development and, as such, does not provide any email-related features. However, our application is written in Java and is deployed on a Java application server. That means we have all the technology that works with Java EE available at our disposal. There are several techniques for sending emails. One of them is Java Mail, which is a complex solution that we can customize to our needs. However, there is a toolkit that looks less cumbersome. Commons Email from Apache Commons. The API is really straightforward. Sending an email requires us to specify outgoing mail server parameters like hostname, port, login credentials, after which we can provide the message and just call send. How do we incorporate Commons Email into our application? Similarly to any other third-party code we could use. Let's download the jar and place it in our webinflib folder. Since this is on our class path, it will automatically become available to the rest of our application, and it will be deployed with it as well. Okay, so now the classes are available and we can in theory send emails. Of course, constructing the email objects every time we want to send an email would be repetitive and boring, to say the least. Instead, naturally, we will provide a service that will send the emails for us. Currently, we want two kinds of emails to be sent: when the user registers and when they request password change. Let's have the corresponding methods in our service. Of course, the implementation of the service should use Commons Email. As we already know, hiding implementation behind the service interface is beneficial, as it allows us to later implement a more efficient solution without propagating that change to the rest of the system. Alright, now we know how we can send emails to an application written with Vaadin. In fact, this is exactly the same as in any other application written in Java. What else is there for us? Let's find out in the next video. Enterprise software rarely uses JDBC connectivity for accessing the database. Instead, various object relational mappings are used, which translate classes into database tables. Our application, Recipe Book, certainly isn't an enterprise-level software, hence we are just fine using straightforward JDBC and SQL container. However, Java has a persistence API known as JPA. This is a mechanism for storing objects in a database and retrieving them back. Behind the scenes, of course, it all ends up as SQL queries being sent to the database. But what is important is the fact that our application doesn't have to worry about that. We just instruct our code to persist or store an object, and we are guaranteed that when we read it, it will be in the state that we saved it. That's the benefit of using JPA. One of the add-ons we can find in the Vaadin directory is named JPA Container. As the name implies, it is an implementation of Vaadin's container that works with JPA. It is available for free in the Vaadin directory. To use the add-on, we need to have a JPA implementation, the common choice being Eclipse Link, and we are good to go. Our code would undergo several changes though. The most significant one would be that we would declare classes that correspond to our database entities, and JPA would do the rest. Needless to say, this significantly improves the readability of our code and allows us to operate on a concrete concept like user or recipe, without the need to worry about items and properties. Naturally, it would still be possible to use those whenever appropriate. That short summary should be enough. We now know what to use when we want to link our JPA application to Vaadin. There is more information available at Vaadin.com webpage and on the official Vaadin forums. And of course, other database solutions, from NoSQL databases to document repositories, can be integrated with Vaadin application, just like most other Java EE compatible technologies. Anyway, let's move on to the next video. Once we have our application up and running, the natural thing that happens is more features are required. This means that apart from implementing new code that would fulfill those requirements, we need to make sure we didn't break anything. How do we make sure? Well, we need to test it. A standard solution is to use JUnit, which allows us to write unit tests that can be run to make sure parts of our software behave correctly. While unit tests never ensure that our software is bug-free, they significantly increase chances of it working correctly. Besides, tests are using our code, meaning that we can define a usable API or catch integration errors earlier. Most importantly, tests define the expected results of running our code, not the exact way of achieving it. This means we can state the requirements and make sure that they are satisfied throughout the development. Another issue we have to consider while developing a web application is that it looks and behaves the same across different browsers. Of course, the majority of users browse the internet with one of the 4 major browsers, but even among those browsers, the implementations of HTML, CSS, and JavaScript vary. How do we make sure our application looks the same across all browsers? Well, we would have to run it in each browser. That would be a tedious task, but it is definitely doable. Of course, once we introduce new code to our application, we would have to test everything again. Can we somehow automate that? The answer to that is naturally. The Vaadin directory contains a commercial add-on named TestBench. It is built on top of Selenium, a leading browser graphical user interface testing framework. We can record user actions in a browser and then use those as a basis for our automated tests. TestBench will take care of the rest, running those macros with different browsers and making sure that they behave all the same across them. Using automated graphical user interface testing comes at a price, of course. We naturally cannot predict every possible scenario the user can come up with, but that is the case with all types of testing. Furthermore, when we modify our UI significantly, our tests probably need to be re-recorded. But barring those limitations, the gain is enormous. We can increase the chances of our software working correctly across many browsers with not that much effort. In complex software development, this investment usually pays off. Therefore, it is good to remember that Vaadin has an add-on that allows us to automate GUI testing across different browsers. The application we develop throughout the course may attract users that want to experiment with food and prepare something based on the recipes we have published. It is hard to expect from such users to have a full-sized computer or a laptop around in the kitchen. Rather, they would use a smaller device, like a mobile phone. Is our application ready for that? Certainly not. Our UI is designed to work on larger resolutions and large displays. What could we do to make it better for those mobile device users without compromising the regular version? We could use TouchKit. It is an add-on to Vaadin that ships with a set of components designed especially for mobile devices. Moreover, it supports designing the application with the concept of screens, something very familiar to mobile applications. Lastly, on top of that, TouchKit supports offline mode. This means that a user can use our recipe book even when there is no connection to the internet. Of course, browsing recipes would be impossible, but adding a comment or a new recipe would work. Changes would be just sent the next time internet connection is available. Since our application's business logic is hidden behind interfaces as different services, it would be enough for us to implement views and bind the component logic to methods of different services, pretty much as it is done right now. So, to conclude this really brief presentation of add-ons, JPA Container makes possible using JPA with Vaadin data model, which is beneficial in all enterprise-level applications that use JPA. TestBench allows us to test the software in various web browsers. Finally, TouchKit enables us to provide a GUI specific to mobile devices. That summary ends the entire video cycle, during which we developed a rather advanced application with Vaadin, from scratch, in just a few hours. If you have any questions or suggestions related to the course, do not hesitate to contact me by email, miki@vaadin.com. Thank you for watching, and until next time.